Everyone, we are Group 29, and today we are going to present our machine learning final project. Our title is Distinguished JJ Lin from Lookalikes, a target-specific binary facial recognition study. This project focuses on a practical and challenging problem in face recognition. Instead of identifying many people, we ask a simpler but more realistic question. Is this person JJ Lin or not? We explored how different neural network architectures perform on the real world and unconstrained image conditions. This is our context. And we'll first introduce the problem and motivation, followed by an overview of our methods and data preprocessing pipeline. Then we'll explain the model designs comparing a traditional neural network with a convolutional network. And after that, we will present our experimental results, discuss the limitations. And to see our background and motivation, face recognition is a well-studied topic, and many systems already achieve high accuracy in controlled settings. However, in real-world scenarios, the problem is often more specific. For example, platforms may only need to verify whether a person is a particular individual. We choose JJ Lin as our target identity not only because he is well-known, but also because many people look similar to him in hairstyle, facial structure, and lighting condition. And this makes the text more realistic and challenging. The main objective of this study is to investigate whether a machine learning model can reliably distinguish a specific target individual from all others in unconstrained images. Instead of general multi-class face recognition, we focus on a binary classification, JJ Lin versus not JJ Lin. We also aim to compare two model architectures, a fully contact neural network as a baseline and a convolutional neural network that can leverage spatial facial features. To see our method, our overall pipeline consists of 4 main stages: data collection, preprocessing, model training, and evaluation. We collected images of JJ Lin and non-JJ Lin individuals from public sources. After preprocessing and augmentation, we trained both NN and CNN models using PyTorch. Finally, we evaluated their performance during accuracy, F1 score, and confusion matches across independent test datasets. To see our datasets, our dataset contains approximately 7,300 images, divided into 2 categories: JJ Lin as a target class and non-JJ Lin, including both lookalikes and unrelated individuals. The images vary significantly in lighting, resolution, pose, and background, which reflects real-world conditions. This variability increases text difficulty but also improves the release of our evaluation. And to see our preprocessing strategy to reduce noise, we applied face cropping, ensuring the models focus on facial regions rather than background or clothing. We preserve RGB color information instead of converting image to grayscale. As texture, shading, and color curves are important for distinguishing similar faces, and all images were resized to 128 by 128 pixels and normalized to stabilize training. For our data formatting, for the neural network baseline, images were flattened into high-dimensional vectors and then reduced to 2056 dimensions using PCA with brightening, which helps reduce redundancy. In contrast, the CNN directly processes the original 188 plus 188 and 3 RGB images, preserving spatial structure for convolutional feature learning. This distinction allows us to fairly compare global feature-based and spectral feature-based models. To see our baseline neural network model. Our baseline model is a fully connected neural network. It takes PCA reduced features as input and passes them through multiple hidden layers with ReLU activation and dropout to prevent overfitting. This model is computationally efficient and serves as a reference point, allowing us to quantify how much improvements come from modeling spectral information. And this is our main model, Convolutional Neural Network. Our main model is a convolutional neural network designed to operate directly on RGB images. It consists of 4 convolutional blocks, each containing convolutional layers, batch normalization, ReLU activation, and max pooling. As the network goes deeper, it captures low-level features like edges, mid-level facial parts, and high-level facial configurations. And this final output is a probability score indicating whether the image depicts JJ Lin. Sorry. Then this is our experimental setup. We evaluated our models using 2 independent test datasets and with the same class distribution. This helps ensure that our results are not biased by a specific split or dataset. And using multiple datasets allows us to better assess generalization performance. And under 80-20 CHANG value split, the neural network achieve an accuracy of 95% and with F1 score of 0.967. Sorry, and the CNN achieve higher performance with 97% accuracy and an F1 score of 0.979. And also the improvement is modest. The CNN consistently reduces false positives, and which is important in target-specific recognition tasks. And for our limitations, and our dataset comes from public, unconstrained sources, and which introduce large variation in quality and ambiguity. And additionally, due to limited access to dedicated GPUs, and we were constrained in model complexity, training duration, and hyperparameter tuning. And the NN baseline relies on the global PCA feature, and which may discard fine-grained facial details. And the CNN, while effective, we was trained from scratch and not compared with pre-trained face recognition models. And finally, our team size was reduced during the semester, and which limited our experimental scope and iteration speed. And to look at our conclusion. In conclusion, this study demonstrates that CNNs provide a more stable and robust solution for target-specific face recognition compared to fully connected networks. And preserving RGB information and spatial structure plays a crucial role in distinguishing visually similar faces. And even through the baseline performs competitively, CNNs consistently deliver better overall reliability. And in our future work, we aim to improve data set quality through more systematic creation, and we also plan to perform extensive hyperparameter tuning and explore pre-trained or hybrid architectures. Finally, extending this framework to multiple target identities would help evaluate its generalizability. So, thanks for your attention. I appreciate your time, and we're happy to answer any question you may have. Thank you.